The final video segment that I'm going to do on this fooling around with the human builder workbench. Now remember, that is not the systematic way of learning things, and I don't pretend to be an expert in this, but as I said, it's a fun workbench. So what I would like to do now is create a mechanism and bring a mannequin and attach that mannequin to this mechanism, so that as the thing moves, the mechanism moves, the mannequin moves with it. So here's what I have done. Something you can pretend that this is the frame of a bicycle. I have 3 parts. Let me move these around so that you can see what they are. I'm going to put the constraints and create the mechanism. Okay, so let's translate everything in Y direction. So this is the paddle, and there is the shaft that goes into that. Okay, let me actually move also this thing in the Z direction, because we're going to do the constraints. Very good, and there. Okay, so first thing I'm going to do is remember, there is a revolute joint between part 1 and part 2, and there's another revolute joint between the paddle part 3 and part 2. So first we're going to anchor the part 1, and then coincidence between the axis of this and the axis of the hole. Okay, and coincidence between the vertical plane of this axle and the vertical plane of the frame. Okay, there we are, and update. Okay, and now let's put the paddle in place. So we have a coincidence between the axis of this hole and the axis of the paddle here, this axis. Okay, and then coincidence between, for example, this, we can do, let's see now, this plane and the plane of this shaft. Okay, update. Alright, now these constraints that I put in there, we're going to turn them automatically into joints, and they're going to be 2 revolute joints. So how do we do that? We go to digital markup, get the magic wand out. There's the magic wand. So new mechanism and auto create. In other words, based on the constraints in the assembly design, create the joints, and obviously we're going to have 2 revolute joints. There we are, one between the part 1 and the axle, so we're going to make it angle driven, 0 to 360, and the other one between the paddle and the axle, also 0 to 360. Okay, needless to say, the mechanism can be simulated. If you want to do that manually, you click on this simulation with command. There's going to be 2 sliding bars. One is going to be responsible for the axle, the other one is responsible for the paddle. Okay, good. So now we're going to bring in our mannequin. So we have to go to the human builder, ergonomics, design and analysis, human builder. Okay, let's insert a mannequin. This was inserting mannequin right there. Okay, and the father product is just, there's only one product here, and we're going to take a man in 50 percentile rank population, and we say okay right there. Let me move this well actually notice that this thing came as a standing situation, initial situation. We can double click on the posture analysis, this posture editor there, and we can turn it into sitting. Okay, and then obviously you have to move this guy up. So let me use the compass, put the compass there and drag it up until I'm happy with the way this guy is sitting there. A little bit further up. Yeah, that's good. And then I'm going to move also to the side. Very good. Okay, so now what we want to do is we want this guy to move his thigh so that it's going to be possible for him to put his foot on that paddle. Let me see now. This is done with forward kinematics, right? Forward kinematics. You click on the thigh, and these are the different degrees of freedom. That's not what I want. I put the cursor on that right click and degree of freedom 2, and now you can move it in this way. Okay, let me see what happened here. That's better. And then we move it, we may want to move this thing a little bit down too, so degree of freedom 2, yep, okay. And I want this fellow to put his heel, on that paddle. And the best way of doing, the easiest way of doing it is using reach. So we say, okay, here is where we want to put the heel, right there. Okay, now it is true that you have to fool around with this so that it looks nicer, but anyway, that's what it is. So we're good. All right. Now what we want to do is we want to make sure that the heel of this is clipped to or attached to that paddle. So that's what you use. That's where you use this. See this paper clip. So I want to do this guy and the surface of that. Okay. And now we're going to go to. Oops. Okay, fine. Now we're going to go to digital mockup. We already created the mechanism. We move this thing out of your way, and we're going to do that manually. For example, right here, look. Now notice that this guy's foot is not moving. There is a reason for that. I expected this thing to move. Why it's not moving? This is something very important. You need to go to tools, options. This is something that you have to activate under ergonomics analysis and design and analysis, human builder. You see this? It says constraint resolution manual. You want it automatic. So this has to be on if you want these things to move together. So now let's try it. See that? This is a terrible motion, but it does work. Obviously, there's no physics here. I just wanted to make sure that all the joints within this guy's body are actually working properly. Okay. Now let's see. Can we make a cartoon here? Let's make a simulation there. Mechanism 1. Okay, so let's do this. Move that thing. And move that thing. Insert. Change the speed here. Rewind and play it continuously. Terrible. I mean, if you want to do a good job, you have to look in the workbench. You have to learn more about it, and basically you can you have a fully developed mannequin with all the joints, all the joints, internal joints already created for you, and you can create mechanism and attach it to the program. Now also remember that if you put proper physics into the motion of this revolute joint, for example, given the speed and things like that, and you can do that, then of course the motion of the mannequin is true physical motion, and there may be discomfort associated with the things like that. You can plot the acceleration of things and of the mannequin joints, and it's fun. I highly recommend that you learn this and then hopefully make some video segment and put it up on YouTube so that other people can learn it. Alright guys?